And hi everybody, so we're going to be looking at this function f, and we're going to do that process of a series of shrinking secants, but we're going to do it in general. So I've set up the function f, and we've picked a general point at some x-coordinate x, so that's this point right here. And we're going to determine the slope of a tangent to our graph of f right there. So the y-coordinate that goes along with this point is f of x. And we know how to calculate slope using our slope formula. So our slope formula just being our y2 minus y1 over x2 minus x1. Now we need 2 points, so we're going to have to pick another point on the function. So I'm going to pick a point just a little bit further ahead. And in fact, when I'm talking a little bit further ahead, I'm going to add some number h, some horizontal distance to it. So this will now have the coordinates x plus h and f of x plus h. So we now have 2 points, and if I connect them, I can create a secant, and I can determine the slope of that particular secant. So filling in my slope formula, I'm going to take y2, this point, so that's f of x plus h, and I'm going to subtract y1, just the f of x value. Then that's our rise. Now I'm going to do our run, so I'll take x plus h and subtract x. Just a little bit of simplifying here. We're going to see that our x values will cancel out. And so we'll be left with f of x plus h minus f of x over h. Now this is the slope of any general secant on the graph. I don't have any specific values, I don't have any name. This actually could work for any function. Now I don't want a secant, I want a tangent. So what I have to do is I have to allow this point to get infinitely close to this point, which means this horizontal distance here of h needs to shrink. So I need to bring this point along the graph until my h value is 0. Now I can do that with limits. So this is no longer the slope of a secant. This will then be giving me the slope of a particular gradient. So I'm going to now call this my gradient at x, or my derivative. Now the way that I communicate that h is going to 0 is I use some limit notation. So I'm going to find the limit of my slope of a secant as this value of h approaches 0. And this is known as our derivative from first principles. Because we don't have any values of x substituted in yet, this is in its most general form. You can use this, if you can evaluate this type of limit, to determine the slope of any tangent to any graph at any point.